Hello dear. Today we will solve exercise 3, page 107. Let I be the midpoint of a chord AB in a circle C of center O and radius R. Here is our circle C, the center O and radius OM or ON, and we have here AB is the chord. Show that OI is the perpendicular bisector of AB. What do you mean by perpendicular bisector? It's perpendicular that passes through the midpoint of the segment. Here we have OA equal to OB, since radii of the same circle are equal, right? So I can say that O is equidistant from both extremities A and B. So O belong to the perpendicular bisector of AB. Here I found the first point. To get a line, I have to search about another point. There is no given about N or M, but here they told me that AI equals to IB. Then I is equidistant from A and B. I can also say that here I is the midpoint of AB. Okay, but they didn't tell me that they are perpendicular. So what to do? O is equidistant from A and B. Then O belongs to the perpendicular bisector. I is also equidistant from A and B. So A also belongs to the perpendicular bisector. Then I can say that the line OI is the perpendicular bisector of segment AB. Okay? Part 2. The straight line OI cuts the circle C in M and N. Here, OI, the perpendicular bisector, if I extend it, here we have point M and another point N. It's the point of intersection of this line with this circle. The straight show that AM here plus AN equals to BN plus BN. How to think? Equal segments, so they should be placed on the perpendicular bisector, and we have OI is the perpendicular bisector. Here there's a theorem that you should know. Every line that joins the center of a circle to the midpoint of a chord is the perpendicular bisector of this chord. Here the center is O and we have chord AB. This line MN or OI or MO or IN, we can name it in different ways. This line here join the center of the circle to the midpoint of the segment AB. Then I can say that MN is the perpendicular bisector of AB. And now what? Since M belongs to the perpendicular bisector of AB, then I can say that MA equals to MB. Here, MA equal to MB. Now, what about AN and BN? N is a point on the perpendicular bisector of AB. Then, NA equal to NB. Since any point on the perpendicular bisector is equidistant from both extremities of the same segment. Equidistant means having the same distances. This means that AN equals to BN. Okay? Now, by comparison, AM plus AM equals to MB proved in the first part, and then AN equals to BN or NB proved in the second part. So this expression is proved. Now exercise 4, page 107. In the adjacent figure, B is the midpoint of segment EF. I have to prove that points A, B, and C are collinear. Collinear means belong to the same line. Here, look, AE equal to AF. This means that A is equidistant from E and F, then A belongs to the perpendicular bisector of EF. Okay, this is the first part. Similarly, CE equal to CF, then C equidistant from points E and F, then C belongs to the perpendicular bisector also of EF. If I join them together, A and C, we will see that AC is the perpendicular bisector of EF, and since the perpendicular bisector is perpendicular to the segment at its midpoint here, which is B, then I can say that A, B, and C are collinear. Now let's see how to write these. AE equal to AF, then A is on the perpendicular bisector of EF. Similarly, BE equal to BF, then B is on the perpendicular bisector of EF, and CE equal to CF, then C is on the perpendicular bisector of EF. Therefore, A, B, and C belong to the same perpendicular bisector. So, A, B, and C are collinear. Okay, I know that such exercises need a lot of attention. So if you please, if you understand it, if you didn't understand it from the first time, try to rewatch the video, and if you have any questions, I'm ready for answering your questions. Thanks for your attention.